Okay, so as you can see, this problem is pretty long. So I'm going to go through it a little bit quick, but if you need to pause this and watch my work, I try to explain my work here with what I've typed out. So the first thing, the problem says to find a quadratic model that fits the following data. So it gives us some speeds, it gives us some accidents. So I'm going to say that this speed column is like our x's. Oops. If we were to graph this, this would be like our x-axis, and y would be our accidents. So the next question to ask yourself is, what does a quadratic equation look like? And it looks like ax squared plus bx plus c equals y, I should put here. So what you want to do next is to make three equations with the 3 points that they gave you. So 60 in our first is like our x. So if I put in 60 squared, that's how I got this 3600. Because I'm going to put 60 into all of my x spots here. So I have a times 60 squared plus b times 60 plus the c equals y. And since y over here is our accidents, that's why it equals 310. And we do that with each of the 3 points. So if we have 80 miles per hour here, that's going to be our x. So in equation 2, I've labeled them equation 1, equation 2, and equation 3. In equation 2, I've done 80 squared, which is 6400 times a, plus 80 times b plus c equals y, and since y is our accidents, that's 160. So you first come up with your three equations. The next is to solve these three equations, and that's what takes a long time. So first, I decided, and you can do it in different ways. This is the way I decided. I looked at equation 2 and equation 3, and I noticed that if I want to eliminate the c's, if equation 2, all these numbers were negative, and then I added the 2 together, then the c's would eliminate. So that's what I've done here, is I multiplied equation 2 by -1, and then I added it to equation 3. So that's all my work here. Once I did that, I got equation 4. I labeled it with a new equation. And that's part of the problem. With these problems, it can get really messy. So if you can label them as best you can, it'll help you keep organized. So I labeled this with equation 4. It's a new equation I came up with by taking -1, timesing it by equation 2, and adding it to equation 3. So that's my equation 4. Then I looked and I said, okay, equation 4 doesn't have a c in it anymore. So if I can get two more equations that don't have a c in it, then I can take those two equations and combine them together. So I looked at equation 1 and equation 2, and I noticed, oh look, the c's, again, they could cancel out if I took equation 1 and I multiplied it by a -1. So I took equation 1, multiplied the equation by a -1, and I added it to equation 2. So once I did that, I came up with this new equation here. I labeled it equation 5. And that's what I was left with here. So in equation 4 and equation 5, the c's have been eliminated. There's no more c's in them. So I looked at equation 4 and 5 now, and that's what I went over to this step here. I took 5 and 4, and what I did was I multiplied equation 5 by -1 and added it to equation 4. When I multiplied 5 by -1, it just changed the signs of all these, but I did that so that these b's would then cancel, because a -20b and a +20b will cancel, and now I'm just left with a new equation with only an a in it. And once there's only one a in it, I can solve for a by getting the a all by itself, dividing both sides by 800, and I got a is 3/16. Then I need to take that a, and what I wrote here is plug our a into equation 4 and solve for b. So I chose equation 4. You could have chosen equation 5 also. But I took 3/16, put it in our a spot here, where the a used to be, and solved for b, which means I got b by itself. So if you follow my steps here, following the arrows, we got b equals -135/4. Then the very last step here, it kind of squished it over here in the edge. But I took equation 1, and again, I could have taken actually equation 2 or 3, but I chose equation 1, and I plugged in our a and our b that we got and found out what our c was. So here's equation 1, but where the a used to be, I put our 3/16. Where the b used to be, I put our -135/4, and I got the c by itself to find out what c is equal to, and that's 1660. Okay, once I have my a, b, and c, I go back up to my original quadratic equation, what it should look like. And here I've circled in yellow. A should be going right here, B should be going in front of the x, and C should be going all alone at the edge, at the end of your equation. So that's what I've done here. I put the A right here in front of the x squared, I put the -135/4, which is our B in front of the x, and I put our C alone. And that's the final equation that is quadratic. It's a quadratic model that fits this data.